So here we have question 9, part A. We have the diagram below, not drawn to scale, shows the relative positions of three reservoirs, B, F, and G, all on ground level. The distance BF is equal to 32 kilometers. So that's B to F is 32 kilometers right here. We have FG is 55 kilometers, so F to G, 55 kilometers. And we have angle BFG. Now you know the angle is located at a letter in the middle, so the angle is at F. So if you go B, F, G, so at F, 103 degrees. So angle BFG, 103 degrees. And we're saying and F is on a bearing of 42 degrees from B. Now you know you're putting a north line on the from, so from B, north line on B, that's why we're in north line here. And we're taking the angle in a clockwise direction. So 42 degrees in a clockwise direction, that's the bearing of F from B. So now for part 1, they want us to determine the bearing of B from F. Now since it's from F, we are putting north line on F. So let's do that. So I have my north line here. And now we want the angle in a clockwise direction. That's going all the way around here to this line connecting F to B. Now before I do that, I recognize that this north line here and this north line here are parallel lines. And once we have parallel lines, we can look out for alternate angles or corresponding angles. Now here I can see the Z. If I were to extend this line further down, we would have our Z here, and therefore this little piece of angle here will be 42 degrees. Now I'm just going to highlight the Z for you. So what we're going to have is the angle here would be 42 degrees. So now this north line, this whole line here is a straight line, so this whole angle here is 180 degrees. So I'm going to put here is 180 degrees. So now we have the 180 plus 42, and that will be the bearing of B from F. So you see, in a clockwise direction, you have 180, then plus 42. So you're going from the north line all the way around to connect to this line that connects F to B. All right, so I have the bearing of B from F would simply be 180 degrees plus 42 degrees. And that will be 222 degrees. So now here we have part 2 where we want to calculate the distance BG, giving your answer to 1 decimal place. So if you look at the diagram that they give us, this is a non-right angle triangle. This is BG, which means we're either using the sine rule or the cosine rule to solve for the missing side. Now if I look at the pattern that I have here, I have this 103 degrees is in the middle of these two given sides, which indicates to me that we have to use the cosine rule to find this missing side. Now, I would label this triangle with the common letters, and we know the common letters represents the length of a side, and the capital letters represents the magnitude of an angle. So F would be 103 degrees. G would be the angle wherever it's supposed to be here, and B would be this angle that's supposed to be here. But for now, the only angle we know is F. So capital F is 103 degrees. Now, opposite to this angle would be the common side F. So if I was to draw a line from F, it will go all the way and touch this side, and that's why this will be common F. If you were to draw a line from B, it will go and touch this side, which will be opposite to B, and this will be common B. And if you were to draw a line from G, it will go here and touch this side, and here will be common G. So now to write the cosine rule, we'll start with F because that's what we want to find. So it's going to be F squared is equal to, the other two sides will be G and B. So G squared plus B squared. And it doesn't matter if you put the B first or the G first. All right. Take away, using back these two letters, G and B, 2GB, cosine the angle, which will be F. So you start with common F, you end with capital F. So now we're going to put in the values for these letters. So F squared, well, F is the side BG. So for common F, I'm going to put BG. So I'm going to have BG squared is equal to, common G is this 32 kilometers, so that's going to be 32 squared, plus B, common B is 55 kilometers, so that's going to be 55 squared for B squared. Take away 2 times G, which is 32, times B, which is 55, cosine the angle F, and the angle F is this 103 degrees. So I'm going to put BG squared is equal to, now what I like to do in this situation is to run this whole thing on the calculator. And of course, we need to know where to put our brackets on the calculator to do this whole thing. So we're going to put brackets here, and we're going to have brackets here. So now I have my calculator up. Look what I'm going to do. So we're going to put open brackets. We're going to put 32 squared. We're going to plus the 55 squared. We're going to close the brackets. We're going to put take away. We're going to open brackets again and put 2 multiply by 32 multiply by 55 multiply by, make sure you calculate in degrees for this, okay? Because our 103 angle is in degrees, right? You know your radians, RAD or GRAD. If you calculate in any of those modes, you're going to get the wrong answer here. So when we press this cosine, so we are multiplied by, right? So cosine, and we're going to put the 103 and close brackets. The calculator is understanding that this 103 is in degrees. That's why you need to have this DEG on top here. So I'm going to press equal, and we get this 4,840.8. Now, seeing that the final answer has to be to 1 decimal place, I'll write this to 2 decimal places. So for the decimal, we have 0.827. I'm going to stop at the 2, and because here's a 7, here's going to go up by 1, so 0.83. So I'm going to write 4,840.83. So now I'm going to have that BG is equal to, because here we have BG squared is equal to this, so BG is going to be equal to the square root of this. All right, so it's square root of 4,840.83. And when we find square root of this, we write the answer to 1 decimal place. So BG is equal to, so here we have the calculator again. So we're going with the square root. So the square root is the second function of the x squared button for me. So second function x squared, and the square root comes up. I'm going to put the 4,840.83. Press equal, and we get 69.57. Now remember, it's 1 decimal place. So stopping at the 5, and after is a 7, so 69.6. So we're going to have BG is 69.6 kilometers. And that's your answer to 1 decimal place. So now for part 3, we have calculate to the nearest degree the bearing of G from B. So we know the from is where we put in the north line. So from B, north line is on B. Now we already have a north line on B here. And we want the bearing of G from B. So from a clockwise direction from this north line, we want to go until we meet the line connecting B and G. And that'll be this line here. So essentially, this is the angle that we want. This would be our bearing of G from B. Now, we already have this part here is 42. So what we need to know is this angle here. So we need to know, call this theta, this angle here. And if you could find this angle and add it to 42, that would be the bearing of G from B. So what I'll do, I'll draw this triangle separately. All right, so here I have my triangle with F, B, and G. I'm going to put in the length of sides, which here is 32 kilometers. Here is 55 kilometers. This angle here was 103 degrees. And what we're trying to find is this angle here, theta. Now, if we also look back at the previous page, we worked out the length of the side BG as 69.6 kilometers. So you can put in that as well. So BG is 69.6. So here I'm going to put the 69.6 kilometers. So essentially, I know the lengths of all 3 sides of this non-right angle triangle. And the reason I'm emphasizing non-right angle triangle, because once it's a non-right angle triangle, it's the sine rule or the cosine rule. Now, yes, if you have all 3 sides, you can use the cosine rule to find the missing angle. But let's see if you can use the sine rule as well. Okay, so we have the length of this side and this angle. And we want to find this angle, and we know the length of this side. So that means the sine rule could work. So let's label the triangle. So if here is capital F, then opposite to that, draw a line from F, come down, touch here. This is common F. This is capital B, draw a line across. Let's do this in green. This would be common B. And this is capital G here. If you draw a line, it will touch here, which will be common G. So what I'm saying is that if you look at the sine rule, all right, we want to find this theta here, which is capital B. So you'll be using common B over sine capital B, and the only unknown there will be the capital B, which is theta, the unknown. The next two things we must know, and we could use the common F over sine capital F. So let's write that out. We'll have B over sine B, and that's the angle B, is equal to, we're using common F, the 69.6, and sine capital F, which is the 103. So common F over sine capital F. So now let's put in the values. Common B is 55 kilometers over sine capital B, and that's the angle theta. So you're going to write theta here is equal to common F is 69.6, and capital F, well, sine capital F is 103, so sine 103 degrees. So what we can do now is cross multiply here. So I'll put equal, and I'll have the sine theta by 69.6. So that's 69.6 sine theta. And then I'll have this 55 multiplied by sine 103. So that's 55 sine 103 degrees. So now we understand that this is 69.6 multiplied by sine theta. So once we transfer the 69.6 across the equal sign, the operation will change to division, and we'll get sine theta is equal to 55 sine 103 degrees over 69.6. So sine theta is equal to, I can just do that whole thing on the calculator. So we press 55 sine 103, press equal, and then you can just divide that by 69.6. And we get 0.7699, so on. Or if you want to do it in one shot, we could put open brackets 55 sine 103, close brackets, and then put divided by 69.6. I can see we still get that 0.76999, so on. Now, seeing that we want to our angle to the nearest degree, I'll just do this to three significant figures. Okay, so 1, 2, 3. After this 9 is a 9, so this 9 will go up by 1, which will cause the 6 to go up by 1, so we have 0.77. So here I'll have 0.77. So now if sine theta is 0.77, then this theta is the sine inverse of 0.77. So theta is equal to, and we go back with the calculator. Let's clear this off, and I'm going to put second function sine. So you see sine inverse comes up, open brackets, and we're going to put the 0.77, close brackets, press equal, and we get 50.353, so on degrees. Now remember, they said they want this to the nearest degree. So 50.3, 3 is less than 5, so the 0 remains the same. So we just go with 50 degrees. So theta is 50 degrees. So now the bearing of G from B is this whole angle here, which is the 42 plus theta, which is 42 plus 50. So I'm just going to write the bearing of G from B will be the 42 degrees plus theta, which is the 42 plus 50 degrees, which is 92 degrees. And that's your answer to the nearest degree. Now we also know that bearings are written using 3 digits. That's the angle. So if you look back at part A, notice when they give the bearing of F from B, it was 042 degrees, which is 42 degrees. So this is good, but if you want, you can write the bearing as 092 degrees. Now moving on to part B, which is the circle geometry. Well, we have this diagram here. Of course, it's not drawn to scale. Shows a circle with center O, so O is the center. We have the points A, B, C, and M are on the circumference. So you can see that A, B, C, and M. The straight line CN is a tangent to the circle. So you're seeing CN here. This is a tangent to the circle. And you can see that there's only one point of intersection here. So CN is the tangent. Okay, so it's saying tangent to a circle at the point C, which means it's touching the circle at point C. and is perpendicular to BN. So this is B to N here, and you see 90 degrees means CN is at right angles to BN. Now for the first part of the question, they want us to determine, giving a reason for our answer, angle ABC. So again, the angle is always at the letter in the middle. So AB will be one arm and BC will be our next arm. So we come here, AB one arm and then B to C another arm. That means this is my angle here. Angle ABC. Now if you look, this line from A to B passes through the center of the circle and touches the circumference at both ends, which means AB is the diameter, and therefore this triangle being formed here that's standing on the diameter would be a right angle triangle. I'll highlight that. So this is my right angle triangle here, and the right angle will be at this point here. So now that we have this triangle in isolation, we have 1, 2 angles and 1 missing. And we know the sum of the interior angles of a triangle is equal to 180 degrees. So first I'll write my reason for this 90-degree angle being here. And this will be angle ACB, or I can say angle BCA, anyone. So angle ACB is equal to 90 degrees. And the reason for that would be angle in a semicircle. So angle in a semicircle. So now we can proceed to finding this angle ABC by adding up the 50 and the 90 and subtracting it from 180 degrees. So angle ABC is equal to 180 degrees, take away 58 degrees plus 90 degrees. So that's equal to, we can just work the whole thing out on the calculator. So we simply have 180, take away open brackets, 58 plus 90, close brackets, and press equal, and we get 32 degrees. So angle ABC is 32 degrees. And my reason will be sum of the interior, so INT full stop is short for interior. This is a symbol for angles of a triangle is equal to 180 degrees. So next up, we want to find out what is angle CMB. So now if you look at the diagram again, this is C to M to B. So that means this is the angle that we want to find. C to M and then M to B. C to M and then M to B. Now I am seeing a cyclic quadrilateral, so I'll highlight it for you. So if you notice, this shape has 4 sides and all 4 vertices touch the circumference of the circle. So here, 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 and here, which would make it a cyclic quadrilateral. Now if you had a vertex that wasn't touching the circumference of the circle, it would not be a cyclic quadrilateral. Okay? Now the thing about a cyclic quadrilateral is that the opposite angles, the opposite interior angles are supplementary, meaning the two of them must add up to 180 degrees. So therefore 58 and this angle here, which is CMB, must add up to 180 degrees. So essentially CMB is equal to 180 take away 58. And that will be 122 degrees. And of course, your reason going to be the opposite interior angles of a cyclic quadrilateral are supplementary. So I'm going to write the opposite, so OPP for opposite, interior, INT full stop for interior, angles of a cyclic quadrilateral, so QUAD full stop for quadrilateral, are supplementary. SUPP for supplementary. All right, and this would be your reason. All right, so this is your answer and this is your reason. Now moving on to part 3 of the question, we're going to find the angle NCM. So that's N to C to M. So that's going to be this little angle right here. So that's NCM. So now I'm seeing that here's a right angle. And this would be a right angle triangle here. And I just found out that this angle here is 122 degrees. So let's put that in. This was 122 degrees. Now this is a straight line. So if I was to subtract 122 from 180, I will get this angle here. So this angle here will be CMN. So I'm going to write that. So CMN is equal to 180 degrees take away 122. And that's equal to 58 degrees. Now the reason for that is basically a straight angle, right? A straight line, the angle is 180 degrees. So straight angle. So I'm going to put in that. This is 58 degrees here, 58. So now we could see 1, 2, 3 angles in this triangle. Only one angle is missing, so sum of the three interior angles must add up to 180 degrees. So now angle NCM is equal to 180 degrees take away the 90 plus the 58. And that will be equal to, and we can work that out on the calculator. We have 180 take away 90 plus 58, close brackets, and that's equal to 32 degrees. So we're going to have 32 degrees here. And that will be angle NCM, and the reason will be the sum of the interior angles of a triangle is 180 degrees. So I'll write sum of the interior angles of a triangle is equal to 180 degrees. Now moving on to question 10, which is your vectors and matrices question, we have for part A transformation T is defined by the matrix. Well, let's say a transformation matrix here. We have a point A, which is negative 2, 3, is mapped onto the point A prime. So A prime is the image of A after the transformation T, right? So A prime AB under T, which is a transformation. Find the value of A and of B. So as I said, you are going to perform the transformation T on this object coordinates, which is A, and you're going to get your image coordinate, which is A prime. So we know we have to write this coordinate as a column matrix to be able to multiply it with the transformation matrix. So the setup goes like this. Your transformation matrix times your object coordinates will give you your image coordinates. So let's write that. Our transformation matrix will be 2, 2, negative 1, 0 times our object coordinates, which is negative 2, 3, and we're writing that as a column matrix. So negative 2, 3 like this. And that's going to give us an answer that will also be a column matrix, which will be A prime. And the first number on top will be A and the number below will be B. Now, when multiplying matrices, we know we multiply rows in the first matrix by columns in the second matrix. So that'll be rows in the first matrix by the single column in the second matrix. So I'm going to have this 2 by negative 2, which is negative 4, plus this negative 1 by this 3, which is negative 3. Then I'm going to have this 2 down here by this negative 2, which is negative 4, plus this 0 by this 3, which is just 0. So we're going to have this negative 4, and you multiply this positive and negative sign, and you get a negative sign. So you get negative 4 take away 3. And this negative 4 plus 0 is just negative 4. So negative 4. Now here I'll add and keep the negative sign. So 4 plus 3 is 7. So that's negative 7 and negative 4. So now this is your A and this is your B. So we're going to have A prime is equal to the negative 7 and negative 4. Therefore, A prime like this is just negative 7 as a coordinate, right? Negative 4. Which means, well, imply that, A is equal to negative 7 and B is equal to negative 4. So now for question 10, A part 2. We want to determine a transformation matrix that maps A prime to A. Now remember this T here mapped A to A prime. Alright? So now we want to do the reverse. So if you want a transformation that's going to map A prime to A now, the image to the object, is going to be the inverse of this transformation matrix that mapped the object to the image. So I'm just going to write t here as 2, 2, -1, 0. I'm going to highlight the leading diagonal. So this here is my leading diagonal. And to get the inverse of this matrix, you have to have the adjoint and also the determinant. All right, so the adjoint is easy. We have the adjoint of t is equal to interchange the leading diagonal. So you're going to have 0 on top and then the 2 below. And then the non-leading, you change the signs on the non-leading. So this -1 turn positive and this 2 will turn negative. So -2 down here and +1 up here. That's your adjoint. Now the determinant of t, you can write it like this, will be the product of the leading, which is 2 by 0. Take away the product of the non-leading, which is 2 by -1. Now 2 by 0 is 0, and this 2 by -1 and this negative sign, well, this negative sign and this negative sign will just get a plus sign, right? So come like I say, -2 multiplied by -1, which will just be +2. So your determinant is just +2. So now t inverse would be 1 over the determinant of t multiplied by the adjoint of t. And that's why you get an inverse. Alright, so 1 over the determinant of t is 1 over 2 times the adjoint, which is the 0, -2, 1, 2. Now, normally I would leave the inverse like this, but because we want the transformation matrix, I'll actually go and multiply and do this out. So a half by 0 is just 0. So this is 0. A half by -2 is just -1. A half by 1 is a half. And a half by this 2 here is just 1. And now this is t inverse. So this t inverse maps the image A prime to the object A. Alright, so t inverse maps A prime to A. So now moving on to part 3, we have another transformation. P is defined by the matrix, and we have the transformation matrix of P. They want to find a single 2 by 2 matrix that represents the combined transformation of T followed by P. So here I have T on top here, and so this is my transformation matrix for T, and this is my transformation matrix for P. Now, once you see T followed by P, I know you'll be tempted to put T first and then P. Now what we have to do is multiply these two matrices, these two transformation matrices, and it's going to go in the reverse order. So we're actually going to multiply the transformation matrix P by the transformation matrix T to get the single transformation matrix for T followed by P. So just like the reverse. Alright, so your answer to this question is the transformation matrix P multiplied by T. So you're going to have 0, 1, 1, -2 multiply by 2, 2, -1, 0. Alright, so to multiply this, you're going to multiply rows in the first matrix by columns in the second matrix. So we'll have our answer is going to be a 2 by 2 matrix, because this is a 2 by 2 multiplied by 2 by 2. The answer is going to be a 2 by 2 matrix. So our first number will be in our first row, first column. I'll show you what I mean. So our answer will be a 2 by 2 matrix like this. You'll have a number here, a number here, a number here, and a number here. Now this first number here is in the first row, first column. That's why I'll multiply the first row by the first column to get this number here. Alright, so 0 by 2 plus 1 by 2. So that's 0 by 2, which is just 0, plus 1 by 2, which is just 2. Now if you want to get a number below here, this number here, this is in your second row but your first column. So you multiply your second row by your first column to get a number below here. So 1 by 2 is 2. And then you're going to have -2 by 2, which is -4. So plus -4. Now I can write it plus -4, but I know it's going to be 2 take away 4, so I can write that one time. Alright, so let's take away 4. Now if you want the number for here, this is in your first row, second column. That's the number up top here. So your number going on top here is in your first row, second column. So you multiply your first row by your second column. So 0 by -1 is 0, plus 1 by 0 is 0. Now the last one is the number down here, which is in your second row and your second column. So you're going to multiply your second row by your second column. So 1 by -1 is -1 plus -2 by 0, which is just 0. So that'll be equal to 0 plus 2 is 2. 2 take away 4 is -2. This is just 0. And -1 plus 0 is just -1. And this would be for a transformation matrix, a single transformation matrix of T followed by P. Now for part B of this part 3, we want to hence find the image of the point 1, 4. So this is our object under this combined transformation. So this is the combined transformation here. So what we want to do is multiply this PT, which is 2, -2, 0, -1, by this object coordinate, and writing this as a column matrix. So that'll be 1 first, then the 4. And that will give you an image coordinate here. So again, we want rows in the first matrix by columns in the second matrix. Now this here is a 2 by 2 matrix, so it's 2 rows, 2 columns. And now this matrix here has 2 rows but 1 column, so it's a 2 by 1 matrix. Therefore, answer is going to be on the outer ends. So answer is going to be a 2 by 1 matrix. So since we know our answer is going to be a 2 by 1 matrix, we're going to get a number here and a number here. So it'll be a 2 by 1 matrix just like this. So if you want the first number that's supposed to go on top here, this is in your first row, first column. So you multiply our first row by our first column here. So 2 by 1 is 2 plus 0 by 4 is 0. And the number down here is in your second row, first column. That's why multiplying our second row here by our first column here. So -2 by 1 is -2 plus -1 by 4 is -4. So I could simply write -4 here. So now this will be equal to, well, 2 plus 0 is 2, and this you're going to add and keep the negative sign, so -6. So the image coordinates is 2, -6. So now moving on to part B, which is the vectors part of the question, we have the diagram below, not drawn to scale, shows a quadrilateral ABCD, in which the vector AB is equal to M, the vector DC is 3 times M, and the vector AD is equal to N. Now they're saying here to complete the statement below on the geometric properties of the following vectors. So we have vector AB and vector DC are. Now if AB is M and D to C is 3 times M, you know, once one vector is a multiple of the other vector, then the vectors are parallel. Therefore, AB and DC are parallel. So my answer for here is parallel. Now here we have the magnitude of AB is something times the magnitude of CD. So these two strokes on either side of the vector means magnitude of the vector, which is the length of the line. So we're looking at the length of the line AB and the length of the line DC. Now whatever the x and y components of the vector M, we don't know. But we know that AB is M and DC is 3 times M, which means DC is 3 times the vector AB. So also the magnitude of DC will be 3 times the vector AB. Now they didn't have it as the magnitude of CD is equal to what times the vector AB. They have AB first. So now that's common sense. If DC is 3 times AB, then AB is just 1/3 of DC. Alright, so AB is 1/3 times CD. Well, the magnitude of AB is 1/3 times the magnitude of CD. Now here for part 2 of the question, we want to express BC in terms of M and N. Now let's put in the arrow for BC, so we're going from B to C. So this is the vector that we want. Now I'm trying to use the triangle law here, but I'm not seeing anywhere that I can make a triangle here that would relate to M and N. But if I were to make a triangle from D to B, let's do that. So from D to B like this, then this vector would relate to N and M. I'll also form a triangle with this here, so I could get the BC in terms of M and N. Now, if this is my resultant vector, let's see how we want this for here. If this is my resultant vector, I want the tail of this resultant to touch the tail of this vector. So I want this vector to go like this. All right, so BC would be BD plus DC. So I'll write that BC will be equal to BD plus DC. Now I have DC, but I don't have BD. That is one in green here. So I'll have to find this vector. So now this is my resultant vector. Therefore, I need the head. The head is on this side here. So this is good. This head is touching this head. So this is good. So what I want is for a tail of this resultant vector, this tail to touch this tail. So therefore, this has to switch around. All right. So therefore, we want negative M plus N will be equal to BD. All right, so let's highlight the part that I want. So this is already N going in this direction. But what I want is for this vector to go in this direction. And this would be negative M. So what I'll have is negative M plus N is B to D. So I'm going to write B to D is equal to BA plus AD. BA plus AD, which is B to A would be negative M plus AD, which is N. And if I can write this the other way around, N take away M, or I can leave it like this. All right, so that's BD. So now we could find BC, which is my BD plus my DC. And BD we found that as N take away M. So that's N take away M plus, and DC is what? DC is this down here, which is just 3M. So now we have our like terms already together. So negative M, which is negative 1M, plus 3M is just positive 2M. So we have N plus 2M. And this is my vector BC. Now, if you don't understand the triangles, you can look at a simple concept. Notice that if I wanted BC, I have the B on this end and it's ending with the C. So on the ends I have B and C, and in the middle I have the same letter. So you can try and make that pattern work for you. If I want BD, notice I have B on this end and D on this next end, and in the middle I have the same letter, which is A. So what you could do, you could say I want BC, put B on one end, C on this end, and for the middle, try to see which point a vector with B has with a vector with C. So if I look to say, okay, a vector with B and a vector with C, what point do they have in common? That'll be D. So I know D going in the middle. And that's how I'm able to get BC. All right. So now I know, and from finding BC, I know I had to get BD. So I write BD. I put the B here, I put the D here. So I know a vector with B and a vector with D have to have something in common. So I look for B and I look for D and I ask, what does these two have in common? What point will they have in common? A vector containing these two will have in common. And you can see that as C. But if I use C, I still don't know the vector BC that we're trying to find. So that's why using BC and CD would not work. So I come here now, they have the point A in common. A vector with B and a vector with D would have this point A in common. And that's why this would work, because I know what is this AD, and I know what is the, well, A to B was M, and let's reverse it as negative M. So that's why we went with this part here. So you can look at it like that if you don't understand the triangle law. Now for part 3 of the question, we have L is the midpoint of CD. So we have C to D here, and L is the midpoint. Oh, so look, L here. All right, so find BL in terms of M and N. So that's B to L. Let's draw that line from B to L. And the vector will be going this direction, B to L. Now, I'd just like to recall that BC was equal to N plus 2M. So that's N plus 2M. So if you're looking at this triangle here, and this is my resultant vector, this is the tail of the vector, so this vector, the tail must connect the tail. Therefore, this vector has to go in this direction. Okay? And therefore, this vector, the head must connect to this head. So it has to go in this direction. Now, the fact that it tells me that L is the midpoint of DC, it means from D to L is a half 3m, and from L to C is a half 3m. So I'm going to put DL is equal to a half 3m, right? Which simply means 3 over 2m. That's the vector DL. And that would also imply that, the vector L to C is also 3 over 2m. Now, seeing that I want the arrow to go in this direction, which is, now, you see this L to C going this way, but I'm going in the opposite direction. So that would imply that C to L is just going to be the negative of this, which is negative 3 over 2m. So now when I write the vector BL is equal to, again, if you want to go to the concept, you put B here, L here, put a plus sign in the middle, and you want to see what both of them have in common. Well, a vector at B and a vector at L, if I look at a triangle, would only have the point C in common. Therefore, C goes here and here. So that's C, put a vector, arrow. But if you look at a triangle, though, this is my resultant vector. This forms my triangle here. And since this is the resultant, this is the tail, so the tail of this vector must connect to the tail of this one. That's why the arrow ought to go this way. And since the head is coming here, the head of this vector must connect to the head here. So that's why the arrow is going this way. So you can see BC plus CL will be equal to the vector BL. Now we already have BC as this n plus 2m. And now we have the vector C to L as negative 3 over 2m. So we're going to have BC, which is n plus 2m, plus CL, which is negative 3 over 2m. So we're going to have n plus 2m take away 3 over 2m. So we can just work this out on the calculator. This is just really 2 take away 3 over 2. So we can just type in 2 take away 3 over 2, and we get a half. So that'll just be a half m. So we're going to have n plus a half m, and that's my vector BL. And that will bring us to the end of this video and the end of this past paper.